Hello and welcome. Find a comfortable position. Let your body grow heavy, sinking into the surface beneath you. Allow your breathing to slow down, becoming a gentle, rhythmic tide. Tonight, we are not going to silence the world. Instead, we are going to listen. We're going to listen past the sounds of your room, past the sounds of the city, past the sounds of the earth itself. We're going to listen to a sound that has been traveling across the universe for nearly 14 billion years. It's a whisper, a faint, persistent hum that fills every cubic inch of space. It is the oldest story ever told, the story of the very beginning. So, close your eyes, breathe deeply, and let us journey together into the mystery of the cosmic whisper, the first sound of creation, and the most profound lullaby the universe has ever sung. Our story begins not in a grand observatory on a remote mountaintop, but in a quiet corner of New Jersey in the 1960s. Two young radio astronomers, Arno Penzias and Robert Wilson, were working with a large, horn-shaped antenna. It was a magnificent piece of engineering designed to detect faint radio waves from the distant Milky Way. But they had a problem, a persistent, annoying hiss, a noise that was present no matter where they pointed their antenna. It was there during the day, and it was there at night. It was the same in the spring as it was in the winter. They checked every wire, every connection. They cleaned the antenna, removing what they humorously described as a pair of pigeons who had made a home there. But the hiss remained. It was a perfectly uniform, steady hum coming from every single direction in the sky. It was as if the very fabric of space was quietly humming a single, unending note. They did not know it yet, but they had accidentally stumbled upon the greatest discovery in the history of cosmology. They were not listening to noise from Earth or from our galaxy. They were listening to the echo of the Big Bang. So, what is this whisper that Penzias and Wilson discovered? What is this ancient sound that permeates all of reality? Imagine the universe in its first moments, not as a dark, empty space, but as an infinitely hot, infinitely dense point. Then, in an event we call the Big Bang, it began to expand. In those first few 100,000 years, the universe was a blindingly bright, opaque fog of plasma. It was a chaotic soup of particles and energy, so hot that light itself was trapped, unable to travel freely. Photons, the particles of light, would emerge, only to be immediately absorbed and re-emitted by the charged particles around them. It was a universe filled with light, but a universe where you could not see. But as the universe continued to expand, it also began to cool. Eventually, after about 380,000 years, it cooled enough for protons and electrons to combine and form the first neutral atoms, mostly hydrogen and helium. This event is called recombination, and at that moment, the universe suddenly became transparent. The light that had been trapped for so long was finally set free, and it flooded the cosmos in every direction. The cosmic whisper we hear today is that very first light. It is the afterglow of creation, the oldest photograph that will ever exist. This first light was not the light we see with our eyes. When it was released, it was incredibly hot and energetic, a brilliant white-yellow glow. But for the past 13.8 billion years, As the universe has continued to expand, the fabric of space itself has stretched. And as it stretched, it also stretched the wavelengths of this ancient light. Imagine a wave drawn on a rubber sheet. As you stretch the sheet, the wave becomes longer and flatter. The same thing happened to the light from the Big Bang. Its wavelength has been stretched from high-energy visible light all the way down into the microwave part of the electromagnetic spectrum. This is why we call it the cosmic microwave background, or CMB. Our eyes cannot see it, but our radio telescopes can. They hear it as a faint, uniform signal, a whisper. It is the universe's oldest light, now transformed by eons of expansion into a gentle cosmic hum. It is a fossil, a relic from an era long before the first star ever ignited, before the first galaxy took shape. It is the universe's baby picture, and it holds the secrets of everything that would come to be. When we look at this whisper with our sensitive instruments, we are doing more than just detecting an ancient signal. We are looking at a snapshot of the past, a perfect image of the universe when it was just a baby, only 380,000 years old. Think about that for a moment. If the entire history of the universe were compressed into a single year, this snapshot would be from the first few hours of January 1st. Everything we know, every star, every galaxy, every planet, including our own Earth, would form much, much later in the year. This light, this cosmic microwave background, has traveled unimpeded across the entire observable universe for billions of years to reach us. It carries with it a blueprint of the early cosmos, a map of what things were like at the very dawn of time. By studying it, we can understand the conditions that led to the formation of all the magnificent structures we see in the universe today. It is our most powerful tool for understanding our own origins. We are, in a very real sense, looking back at the seed from which our entire reality has grown. One of the most remarkable things about this cosmic whisper is its uniformity. It is almost perfectly the same in every direction we look. This uniformity tells us something profound about the early universe. It was incredibly smooth and homogeneous. The temperature of this background radiation is a mere 2.725 degrees Kelvin. That is just under 3 degrees above absolute zero, the coldest possible temperature. This is the background temperature of empty space, far from any star or galaxy. It is deep, profound cold, but it is not a harsh or violent cold. It is the calm, still cold of immense age, a temperature that has been slowly dropping for billions of years as the universe expands and cools. When you look up at the night sky, in the dark patches between the stars, you are looking at this temperature. Your eyes see only blackness, but a radio telescope sees a faint, uniform glow. A gentle warmth left over from the fire of creation. This incredible consistency across the entire sky is one of the strongest pieces of evidence for the Big Bang theory. Only a universe that began from a single, hot, dense state could produce such a perfectly smooth afterglow. While the cosmic whisper is incredibly uniform, it is not perfectly uniform. And in these tiny imperfections, we find the secret to our own existence. When our most sensitive satellites, like the Planck spacecraft, mapped the cosmic microwave background, They found minuscule variations in its temperature. These are tiny fluctuations, differences of only about 1 part in 100,000. On a map of the CMB, they appear as subtle patches of slightly warmer reds and slightly cooler blues. These are not errors in measurement. These are real. They are the seeds of all structure in the universe. In the early, soupy universe, some regions were infinitesimally denser than others. These denser regions had slightly stronger gravity. Over millions and billions of years, that extra gravity pulled in more and more matter. These were the cosmic seeds from which everything else grew. The slightly denser, warmer spots were where matter began to clump together, eventually forming the first stars and galaxies. The slightly less dense, cooler spots became the great voids, the vast empty spaces between galactic clusters. When you look at a map of the CMB, you are looking at the cosmic blueprint for the universe. You are seeing the gentle ripples in the fabric of the early cosmos that, over eons, would grow into the magnificent cosmic web of galaxies we see today. We are here because of those tiny, almost imperceptible fluctuations in the whisper of creation. Our ability to listen to this whisper has grown ever more refined over the decades. Penzias and Wilson first heard it with their horn antenna on the ground, but Earth's atmosphere interferes with the signal, blurring the fine details. To get a truly clear picture, we had to go to space. In 1989, NASA launched the Cosmic Background Explorer, or COBE satellite. COBE gave us our first clear map of the CMB, confirming its perfect black body spectrum and discovering those all-important temperature fluctuations for the first time. It was a revolutionary moment. Then came the Wilkinson Microwave Anisotropy Probe, or WMAP, launched in 2001. WMAP gave us a much sharper image, a high-definition photograph of the infant universe. It pinned down the age of the universe, its composition, and its rate of expansion with incredible precision. And most recently, the European Space Agency's Planck satellite, launched in 2009, gave us the most detailed map of all. Planck's instruments were so sensitive, they could detect temperature variations of a few millionths of a degree. Each of these missions was like upgrading our ears, allowing us to hear the cosmic symphony with greater and greater clarity. They turned a simple hiss into a rich tapestry of information, revealing the deepest secrets of our cosmic origins. But can we actually hear this whisper? The cosmic microwave background is a form of light, not sound. Sound waves need a medium to travel through, like air or water. Space is a near-perfect vacuum, so sound cannot travel across it. However, we can translate the data from the CMB into sound. This process is called sonification. Scientists can take the tiny frequency differences in the CMB's temperature fluctuations and map them to audible frequencies. When they do this, the result is a deep, fascinating sound. It is not a clear melody, but a complex, resonant hum filled with rising and falling tones. It sounds like a deep, cosmic drone. Some have described it as the sound of a giant, otherworldly wind chime, or the rumble of a distant, impossibly large ocean. This sound represents the pressure waves, the sound waves that were rippling through the plasma of the early universe before the light was released. These were the first sounds of the cosmos. So, in a way, The CMB is not just the first light, but it also carries the imprint of the first sound. It is the petrified echo of the universe's first song. As you drift deeper into relaxation, imagine you can hear this sound, a low, steady hum that has been vibrating since the dawn of time, the true sound of silence. If our eyes were sensitive to microwaves instead of visible light, the night sky would look completely different. We would not see the familiar pinpricks of stars or the hazy band of the Milky Way. Instead, the entire sky, in every direction, would be filled with a soft, uniform glow. There would be no darkness. Every point in the heavens would radiate this gentle, ancient light. The color of this glow would correspond to its temperature of 2.725 Kelvin. It would be a faint, ethereal luminescence, a color that our minds can barely comprehend. The subtle temperature fluctuations would appear as almost imperceptible shifts in the hue of this glow, gentle swirls of a slightly warmer orange against a backdrop of a slightly cooler blue. It would be like being inside a softly glowing cosmic sphere. There would be no single source for this light. It would simply be there, everywhere, all at once. This is the true background of our reality. The stars and galaxies we see are just beautiful, luminous decorations painted on top of this much older, much more fundamental canvas of light. It is a reminder that even in the deepest, darkest void, there's still light, the ancient, fading light of our own creation. One of the most profound aspects of the cosmic whisper is its omnipresence. It is not coming from a particular star or a distant galaxy. It is coming from everywhere at once. If you were to travel to the most distant galaxy we can see, and you pointed a radio telescope into its sky, you would detect the exact same whisper, the same hiss, the same temperature, coming from every direction. This is because the whisper is not a signal traveling through space, but rather a property of space itself. It is the leftover energy of the Big Bang, filling the entire volume of the universe. It is a universal echo. Imagine you are in the center of a perfectly spherical room, and you shout. The echo would come back to you from all directions at once. The CMB is like that, but on a cosmic scale. The shout was the Big Bang, and the echo has been traveling for 13.8 billion years. We are not at a special center. Every point in the universe is at the center of its own observable sphere. And so, every observer, everywhere in the cosmos, is bathed in this same ancient light. It is the one thing that connects everything, a shared heritage for every star and every planet across the vast expanse of space and time. Let us follow the journey of a single photon from this ancient light, a single particle of the cosmic whisper. Our journey begins 380,000 years after the Big Bang. The universe has just become transparent. Our photon is born into a cosmos of unimaginable brightness and simplicity. It begins its journey, traveling at the speed of light through a universe that is still very young. At first, the universe is a smooth, homogeneous sea of hydrogen and helium gas. There are no stars, no galaxies. It is a period astronomers call the cosmic dark ages. For hundreds of millions of years, our photon travels through this darkness. Then, slowly, gravity begins to do its work. The first stars ignite. Giant, brilliant blue stars that live fast and die young. Our photon passes by these nascent galaxies, continuing on its journey as the cosmic web begins to take shape. It travels through vast voids, past giant clusters of galaxies that are themselves forming and colliding. It witnesses the birth of our own Milky Way galaxy. It sees the formation of our sun and our solar system from a swirling cloud of gas and dust. All this time, it continues its unwavering path. Finally, after a journey of 13.8 billion years, this single ancient particle of light ends its journey. It enters a radio telescope on a small blue planet called Earth. Its long story is finally heard. Every particle of the CMB that we detect has a similar story. Each one is a messenger from the dawn of time. The cosmic whisper provides some of the most compelling evidence we have for the expansion of the universe. The very fact that the light is in the microwave part of the spectrum is a direct consequence of this expansion. When the light was first emitted, it was high energy with a short wavelength. But as it traveled through space, space itself was expanding. This expansion stretched the wavelength of the light, shifting it down the electromagnetic spectrum. This phenomenon is known as cosmological redshift. It is similar to the Doppler effect, where the pitch of a siren sounds lower as it moves away from you. In this case, it is not that the source of the light is moving away from us, but that the space between us and the source has expanded. The amount of redshift we observe in the CMB tells us precisely how much the universe has expanded since the light was first released. It is a cosmic measuring stick. It allows us to wind the clock backwards, to calculate the size and state of the universe at different points in its history, all the way back to the Big Bang itself. The whisper is not static. It is the signature of a dynamic, evolving cosmos, a universe that began in a blaze of glory and has been expanding and cooling ever since, carrying this an ancient echo along with it for the ride. Within the near-perfect uniformity of the cosmic whisper, there are mysteries, anomalies that do not quite fit our standard models of cosmology. Perhaps the most famous of these is the CMB, cold spot. It is a vast region of the sky, much larger than expected, that is slightly colder than the average temperature of the CMB. While we expect to see random cold and hot spots due to quantum fluctuations in the early universe, this particular spot is a statistical outlier. It is too big and too cold to be easily explained by chance. Scientists have proposed many theories to explain it. Perhaps it is an instrumental error, though multiple satellites have confirmed its existence. Perhaps it is caused by a massive supervoid, a colossal region of space between us and the CMB that is unusually empty of galaxies. Such a void could have a subtle cooling effect on the light passing through it. But the most tantalizing and most speculative possibility is that the cold spot is something else entirely. Some physicists have suggested it could be a bruise, a scar in our universe caused by a collision with another universe in the distant past. A faint hint that we may be part of a much larger multiverse. The cold spot remains one of the great unsolved puzzles in cosmology. A mysterious, cool patch in the warm afterglow of creation. Another puzzling anomaly hidden within the cosmic whisper is something astronomers have controversially nicknamed the axis of evil. This name is, of course, just a bit of scientific humor, but the mystery it represents is very real. When scientists analyzed the detailed maps of the temperature fluctuations in the CMB, they found that some of the largest scale patterns were not as random as they should be. They seemed to be aligned with each other, and strangely, aligned with the plane of our own solar system. This is completely unexpected. According to the standard cosmological principle, the universe should be isotropic, meaning it should look the same in all directions on a large scale. There should be no preferred direction, no special alignment. The fact that the largest features of the CMB seem to line up with our little corner of the cosmos is a profound puzzle. It could be a massive statistical fluke, a 1 in 1,000 chance that we just happen to observe. It could be a subtle, unaccounted for effect from our own galaxy contaminating the signal. Or it could be a hint that our understanding of the universe is incomplete. It could be pointing towards new physics or a different shape, a different topology for the universe than we currently imagine. The axis of evil is a quiet, nagging question mark painted across the entire sky, a subtle discord in the otherwise perfect cosmic harmony. The cosmic whisper is both a window and a wall. It is a window that allows us to see the universe in its infancy, to study the conditions of the cosmos just a few 100,000 years after its birth. It is an incredible gift, but it is also a wall. The light of the CMB comes from the moment the universe became transparent. Before that, the universe was an opaque fog of plasma. This means we cannot see past that point using any kind of light. No telescope, no matter how powerful, will ever be able to take a direct picture of the Big Bang itself, or the moments immediately following it. That era is forever shrouded from our view behind this wall of light, this surface of last scattering. So what came before? What happened in those first 380,000 years? Our theories, like the theory of cosmic inflation, give us a mathematical picture of that time. We can infer what happened by the patterns we see imprinted on the CMB, but we cannot see it directly. To peer beyond the whisper, we would need to look for other messengers from that primordial era, perhaps gravitational waves, ripples in space-time itself, or ghostly particles called neutrinos. These could travel through the opaque plasma and bring us news from the other side of the wall. For now, the whisper marks our horizon in time, the farthest back we can look, and a tantalizing veil over the ultimate beginning. The cosmic whisper is not just a picture, it is a recipe. By studying the precise patterns of the hot and cold spots in the CMB, cosmologists can determine the exact ingredients that make up our universe. The analysis is incredibly sensitive, like a cosmic DNA test, and the results are astounding. The recipe for our universe is as follows. About 5% is ordinary matter. This is the stuff we are made of. The atoms that form stars, planets, trees, and people. Everything we have ever seen or touched makes up only a tiny fraction of the cosmos. About 27% is dark matter. This is a mysterious substance that does not interact with light. We cannot see it, but we can detect its gravitational effects, holding galaxies together. We know it is there, but we do not know what it is. And the remaining 68% is dark energy. This is an even more mysterious force, a sort of anti-gravity that is causing the expansion of the universe to accelerate. The CMB provides the most precise measurements we have of these components. It tells us that we live in a strange and beautiful universe, and that we have only just begun to understand its fundamental nature. The vast majority of reality is made of ingredients that are completely invisible and unknown to us. The whisper reveals not only what we know, but the profound scale of what we do not. Let us return to the idea of the cosmic whisper as a sound. We can think of the early universe as a musical instrument, a giant cosmic bell that was struck by the Big Bang. The plasma that filled the early universe sloshed around under the competing forces of gravity and pressure, creating vast sound waves. The denser regions, pulled together by gravity, would heat up and push back outwards, creating oscillations like a vibrating string. The patterns of hot and cold spots we see in the CMB are the frozen imprint of these sound waves at the moment the universe became transparent. The size of these spots corresponds to the wavelengths of the sound. By analyzing the different sizes of the spots, scientists can pick out the fundamental note of the universe and its overtones, just like a musician analyzing a chord. This acoustic analysis of the CMB is one of the most powerful tools in cosmology. The relative strength of the different overtones tells scientists everything from the shape of the universe to the density of its different components. The whisper is not a random noise. It is a complex and beautiful symphony, a piece of music that was composed in the first moments of time and has been playing across the cosmos ever since. And with our instruments, we have finally learned how to listen to it. There is a beautiful and humbling way in which we have all, unknowingly, been connected to this cosmic whisper our entire lives. If you are old enough to remember old analog television sets, you will remember the snow or static that would appear on a channel with no signal, that dancing pattern of black and white dots, accompanied by a soft, hissing sound. Most of that static was just random noise from the television's own electronics or local radio interference. But a small fraction of it, about 1%, was something much more profound. About 1% of that static was the cosmic microwave background radiation. The horn of the television's antenna was, in its own small way, a radio telescope. And it was picking up the same ancient signal that Penzias and Wilson found. The echo of the Big Bang, the whisper of creation. For decades, in homes all around the world, people were unknowingly witnessing the oldest light in the universe, a direct, tangible connection to the origin of all things, appearing as a random flicker on a screen. It is a reminder that the cosmos is not just something far away, out there in the dark. It is here. It is everywhere. Its faint, ancient energy is passing through this room and through you at this very moment. What is the future of this cosmic whisper? As the universe continues its relentless, accelerating expansion, the whisper will continue to change. The same process of cosmological redshift that stretched the light from the visible spectrum into microwaves will continue. The wavelengths of the CMB photons will get longer and longer. They will shift from microwaves into even lower energy radio waves, and the temperature of the background will continue to drop. Billions of years from now, the background temperature of space will be a fraction of a degree above absolute zero. The whisper will become fainter and fainter, harder and harder to detect. Eventually, in the far, far distant future, when the universe is trillions of years old, the whisper will have faded almost completely. Its wavelength will be larger than the observable universe itself, rendering it effectively undetectable. The echo of creation will finally fall silent. Future civilizations, if any exist, may live in a universe where the evidence of the Big Bang has been erased by cosmic expansion. They might look out at a dark, empty sky and conclude that the universe is static and eternal with no beginning. We are fortunate to live at a cosmic golden hour, a time when the whisper is still loud enough for us to hear and to learn the incredible story of our origins. There is a profound silence that the whisper represents. It is the sound of a universe before complexity, before structure, before life. When the CMB was released, there were no stars to shine, no planets to orbit them. There were no galaxies performing their slow, gravitational ballet. The entire cosmos was a simple, quiet place, filled with a uniform glow and vast, cooling clouds of hydrogen and helium gas. It was a universe of pure potential. The whisper is the sound of that potential. It's the sound of a universe on the cusp of becoming everything we know. Listening to it or contemplating it is a way of connecting with that primordial state of simplicity and peace before the noise and complexity of our modern lives, before the struggles and triumphs of human history, before the earth itself had even formed. There was this gentle, all-pervading hum. It is a fundamental baseline of reality, a reminder that beneath all the layers of complexity, there is a deep and abiding stillness, a quiet that has persisted for almost 14 billion years. It is the ultimate sound of peace, the lullaby of the void. And so we bring our journey back to you, lying here, breathing softly. This ancient whisper is not just a scientific curiosity. It is a part of you. The atoms in your body, the carbon, the oxygen, the iron, were forged in the hearts of stars that lived and died long ago. Those stars, in turn, were born from the clouds of gas that were seeded by the tiny fluctuations in the cosmic microwave background. You are a direct descendant of those tiny ripples in the fabric of the infant universe. The whisper is your oldest family photograph. The energy from that first light is passing through you right now at this very moment. It does not harm you. It does not interact. It simply passes through, a constant, silent reminder of your cosmic lineage. Feel that connection now. Feel the stillness of that 2.7 degree Kelvin temperature. The deep peace of intergalactic space. Feel the gentle, persistent hum of creation that vibrates in every particle of your being. You are not separate from the universe. You are a part of it. You are a way for the universe to know itself. And in the quiet moments, as you drift off to sleep, you can listen. and you can hear its oldest, most gentle song. Tonight, we have journeyed back to the very edge of time. We have listened to a faint hiss in a radio telescope and heard in it a profound cosmic story. The story of a universe born in a flash of light, a universe that expanded, cooled, and allowed the first atoms to form. We saw how the light from that moment, the cosmic whisper, has traveled for 13.8 billion years to reach us, stretched and cooled into a faint microwave glow. This whisper is not just a sound. It is a map, a recipe, and a time machine. It shows us the seeds of galaxies. It tells us the ingredients of our reality. And it carries the echoes of the very first moments of existence. It is the most powerful evidence we have of our own origin story. And it is a source of incredible peace, a constant, unchanging hum that underlies all of reality. Thank you for joining this journey tonight. May the gentle whisper of the cosmos quiet your mind and guide you into a deep and restful sleep. As you drift away, I leave you with a final thought to ponder in your dreams. If you could send a single one-word whisper back through time to the infant universe, what word would you choose? Sleep well.